All right, hello, welcome back. Today we are going to keep building off of our understanding of when a relationship is proportional and our constant of proportionality and look at a way that we can start to solve proportions. So a proportion happens in an equation that states that two ratios are equal. So that's why when we've been looking at proportional relationships, they had to have a constant, that constant of proportionality, because that is saying that those ratios are equal. Now, we can do things to compare ratios just by like finding that constant of proportionality, but there's another thing that we can actually do, that when a pair of ratios forms a proportion, we can also look at something called their cross products. And what that means is we're basically making kind of a cross or an X, and products means multiplication. So what we're going to do is we're saying that A times D has to equal B times C. And if those two products are equal, then it's proportional. And the really cool thing about this is that this allows us to take numbers that we're looking at and solve proportions. So solve for missing values, because we're looking at it as part of an equation. So just really quickly here, we're going to go through a couple of examples. All I'm going to do is I'm going to multiply our cross products. So we're going to determine is 5 times 24 the same as 6 times 20? Well, 5 times 24 is 120, and 6 times 20 is also 120. And since 120 is equal to 120, we know that this is, yes, a proportional relationship. Now, could you also compare the rates of their constants of proportionality and do like 5 divided by 6 and 20 divided by 24? Yes, but this is just simply another strategy. All right, so let's look at our next one. So we're going to check, is 3 times 8 the same as 2 times 15? So 3 times 8 is 24, 2 times 15 is 30, and since 24 is not the same as 30, these two values do not form a proportion. All right, so why don't we go ahead and jump down to number 7 and 8, and you would pause the video and I want you to try both of those on your own and see if they form a proportion. All right, so for number 7, we're going to find 0.5 or 1/2 times 40, and we're going to check if that is equal to 1.5 times 18. Well, half of 40 is 20, and 1.5 times 18 gives us a value of 27, so these are not equal, so they are not proportional. On our next one, we're going to take 16.2 times 38, and we're going to check to see if that's the same as 9 times 68.4. So 16.2 times 38 ends up being 615.6, and 68.4 times 9 ends up being 615.6. So yes, these do form a proportion. All right, so now that we know that cross products can form a proportion, the thing we're going to look at next is a way that we can use cross products to help us solve a proportion. So we're going to start by setting up our cross products. So in this case, we have 16 times 3 has to equal 12 times x. So I can do 16 times 3, and 16 times 3 is 48, and that has to equal 12 times x. So if you think back to our equations unit, since we're multiplying, what we're going to end up doing is dividing both sides by 12 to make that coefficient to x the value of 1. So now we know that x equals, and then 48 divided by 12 is 4. So 4 is the value that we could put into this proportion that would make it true. All right, so let's try another one. So let's just do number 10. So on this one, I'm going to do 7 times k has to equal 21 times 8. So we're going to keep 7k because we don't know what k is yet. And then 21 times 8 gives us a value of 168. I'm going to divide both sides by 7. So our coefficient is 1, so now k is equal to a value of 24. Now, is this the only way that you can solve proportions? No. So for example, on this one, if you had looked here, you might also say, oh, well, I know that 7 times 3 is 21, so then 8 times 3 is 24. That is another way that you definitely could still solve proportions. The reason that the cross products works really well is instances like, for example, here, where 5 doesn't multiply into 26 evenly. It gives us a way to find that value a little bit quicker maybe. So in this case, if you want to pause the video and try these next two on your own. Here we're going to have 5w is equal to 26 times 6. And 26 times 6 is 156. So we divide both sides by 5. And once again, it doesn't matter which way you do your cross products, right? Because it's an equation, they can flip back and forth. W is going to equal 31.2. And on our last one here, we have 63a is equal to 14 times 9. 14 times 9 is 126. So I'm going to divide both sides by 63. And a is equal to 2. Now we're going to start to look at situations where we see proportions in word problems and how we can use proportions to help solve word problems. Now, the biggest thing with proportions in word problems is getting it set up. So like on our first page of our notes, we had the proportions already set up, so it was really easy to just look at like, yep, here's cross products and go from there. With word problems, we have to do the setting up, and so we have to make sure that we are always going to stay consistent. So when we're doing that, it means that we have flexibility in how we set up our proportions, but it has to be set up the same way. So for example, in this first one, right, we're looking at miles per hour compared to hours per mile. So it's not consistent. Even though we're comparing the same values, notice it's miles compared to hours on top and then hours compared to miles on the bottom. So this would not be the correct way to set up a proportion. Whereas on the right side, we can see that we have miles on top in both rates or ratios, and we have hours on the bottom for both of those. So that is the way that we would want to set up our proportion. So just keeping those units consistent. So miles on top on the left, miles on top on the right. All right, so looking here, Pete drove 224 miles in 4 hours on Saturday. If he drives at the same rate on Sunday, how long would it take him to drive 490 miles? Looking at this, our first rate is that he drove 224 miles in 4 hours. So I'm going to go ahead and set that up. So it's 224 miles in 4 hours. And we want to use that to figure out how long it would take him to drive 490 miles. So since they give us miles, we know we're going to keep it consistent, miles on the top. So it's going to be 490 miles and we're going to compare that to x, because that's what we're trying to figure out, is the number of hours. And now we're just going to do like we did before. So here it's going to be 224x, because that's our cross product, has to equal 490 times 4. And 490 times 4 is 1,960. And we have 224x equal to that. I'm going to divide both sides by 224. So in the end, x is equal to 8.75 hours, or because it's a decimal, we could also say it's 8 3/4 hours. All right, so let's look at number 2. Approximately 4 out of 5 students in Mrs. Haynes' 7th grade math class have cell phones. If there are 365 students in the 7th grade, how many would you expect to have cell phones? So I want you to pause the video and set up your proportion first, and then check to see how you do. So we know 4 out of 5 students in her class have cell phones. So we're going to set that up as have over 5 is the total students. And we want to know, if there are 365 students in the 7th grade class, how many have a cell phone. So we don't know how many have a cell phone, but we know there are 365 total students. So that's the way we would set up our proportion, because we have to have, total to total. And now we just go ahead and solve. So we have 4 times 365 has to equal 5x. 4 times 365 is 1,460. And I had this written out before, so don't just think that I magically know all this multiplication. Is equal to 5x. We're going to divide both sides by 5. So x is equal to 292 students that have cell phones. All right, so if you want to pause the video and try the next two on your own, I'm just going to set up the proportions and then also give you the answer. Now remember, with proportions, you could flip them around, but I typically set them up in the order that they're given. So go ahead and pause the video and then you can check your work. This one is, we have 100-ounce jug to wash 64 loads. And we have a 150-ounce jug, and we want to know how many loads that could wash. In the end, x is equal to 96 loads of laundry. And if you did number 4, I would personally convert the 1 1/4 to a decimal. So we would have 1.25 cups to make 8 pancakes. So we want to know how many cups of milk are needed to make 20 pancakes. And then if you would solve this, x would equal either 3.125 or 3 1/8 cups of milk.